Hey guys, here is the Desmos demonstration for function transformations. If you're not familiar with Desmos, it is excellent. I highly recommend learning how to use it and work with it. It's free, completely easy. All you have to do is go to desmos.com and then you have it, nice and simple. So if you just go to desmos.com, it's going to open you up here. You just want to click Start Graphing. Okay. So what it gives us is it gives us a nice little graph here, which we can adjust using these settings. We can change kind of whether we have a grid, if we want to do polar grid, axis numbers, minor grid lines, x-axis kind of. This is nice. It can change the range if we want to go. Right now we're going from -10 to 10, and then we're just kind of keeping it square. You can change those to be whatever you want. The step right now is just kind of how far the numbers go apart. Radians, degrees are different things you need, but nice and simple. Okay. Then over here is where you can type in any function. So let's say we want to graph the function, say f of x equals absolute value x plus 2. There we have it. There's absolute value of x plus 2, which now that you guys have watched the video on function transformations, you know that this is, if we look at this, so let's actually create a, so we'll change that to g. Then I'm going to create another function, f of x, absolute value of x. Okay. So this is our parent function, fx equals absolute value of x. Here, g of x is equal to f of x plus 2, which if you want to think of it, you can think of this as f of x plus 2. Get rid of it that way. So this is affecting the input, right? It is a horizontal transformation. It's addition or subtraction, so it means the shift. Horizontal transformations are counterintuitive, which means this is not moving us to the in positive direction, but actually in the negative direction, 2 spots. And we can see blue was our parent function, red is our transform function. So that was kind of neither here nor there, not what I was looking for, but just kind of showing you how to work Desmos, kind of nice and cool. You can do a lot of fun things with it, okay? But what I want to show you guys right now is I want to go here. So if we click on this little menu, we get this guy here. And if we scroll down this list, there are 3 transformation kind of built-ins. We're going to be talking about the first 2. That one there is for inverses, which is something we'll talk about later this term. So translating a function. Translation is another word for shift. Okay. Now, another cool thing you can do in Desmos is you can add sliders. So you can add these kind of arbitrary variables, which then get these sliders on them. So I'm going to set them both to 0. And in doing so, we can see that, so our parent function, this is in red, and it is this x squared plus sine of 3x. This is just a function that is used because it has a very unique shape. There's no symmetry to it, so it's very clear to see how things are moving. And our transformation, g of x, is transforming our parent function by applying a horizontal shift and a vertical shift. Now, we can do all of these transformations all at once. We could do big, crazy, monstrous things. Sorry about that. Big, crazy, monstrous functions with transformations. But for our class, we're going to keep it fairly simple. We're going to, stick to about 2 or 3 transformations, maybe 4, if we're combining like a scaling and a reflection. So this combines both a vertical and horizontal shift. And so if we look at h, okay, our h value is affecting us here. Now, as I make h positive, okay, so let's say I go to 3. If I can go to 3. There we go. So notice I went to positive 3 and it went in the positive direction, but that's because this is f of x minus h. So the equation here would be f of x minus 3, okay, which f of x minus 3 is still following that counterintuitive model, right? Since this is x minus 3, it's actually moving us to the right 3 units. And we can see that if we click on this point here, it will kind of hold that for us, and then click on this one here. That one's not good. Let's do this one here. That's a nice point. 0, 0, 3, 0. Okay. So we can see here on our parent function, it goes to the point 0, 0, and on the transform function, it goes through 3, 0. If we look at this here, it goes through negative 0.427 and up to 2.573, which if you use your calculator or if you're good at mental math, add 3 to this and you get that right there. So we can see that it just shifted our graph over 3. Notice the shape of our graph is still the same. It still kind of goes down at the same distance. It still kind of has these same peaks at the same kind of spots. So it doesn't change a whole lot else other than it just slides our graph over to the left or to the right. Let's take this back to 0. And let's move k. So as k goes up, we see that our graph goes up. As k goes down, our graph goes down. Again, the overall shape of our graph is still the same, right? We still have these same peaks. Now, the difference here is that notice our inputs are the same, but our outputs are different. That makes sense because a vertical transformation is affecting the output of our function, not the input. So our inputs would not change no matter what. Okay, so there's function transformation using the translation feature. I highly recommend you guys come in here to Desmos and just kind of play around with these. It'll help you kind of get a better sense of what's going on. So now let's jump over to scaling a function. So I want to make both of these 1. And there's another change I want to make. So notice how they define their horizontal scaling. By defining it like this, it kind of changes the way it works. I like to do it like this because it's a little simpler. We don't have fractions in there, which I know you guys are all terrified and hate fractions. But this way it also maintains that kind of counterintuitive nature of the input. So what I'm going to do is I'm actually going to limit these to 0. Let's go 0 to 10. And 0 to 10. Okay, so the reason, I don't want 0, we want that 1. The reason I am doing it that way is so that way we don't have the negative issues. So as b gets bigger, right, so b is affecting us horizontally. So this is either going to stretch our graph side to side or it's going to shrink it in side to side. Now remember, since this is horizontal, it acts counterintuitively, which means that if b is bigger than 1, it's going to shrink our graph in. And watch what happens as I move the slider for b bigger. It shrinks our graph in. Now, one thing that's really kind of nice to notice, remember, it will have the same y-intercepts, which is both 0, 0 on this function here. But if we look at, because this is just horizontally changing, right? It looks kind of like, especially if you look over here, it looks like, oh man, it's like stretched it out, like this kind of stretching up. But we can see here that from these points, they have the same output. The height of that little peak there, we can do it with this little dip here, is the same. They both have the same height. It didn't affect it vertically at all. It only squished it in. Now, if I bring this less than 1, you see that it starts to stretch our graph out. Okay, really nice and kind of a cool way to think of this. So bring it back to 1. Now we do the same thing with a, right? Remember a, so that's affecting the vertical pieces of this function. So that means that since it's affecting us vertically, it means our x-intercepts are going to be the same. So these 2 points will not change, but everything else around it will. And since it's vertical, it's intuitive, which means that a gets bigger, it's stretching it out. And so here, notice that these peaks now occur at different heights, but they still occur at the same point, at 0.681, or the same input, because this is only a vertical effect, vertical transformation. Okay, and as a gets smaller, below 1, it shrinks it down. But notice that all the time, these 2 points, these x-intercepts, never change. So as I move it around, those points stay the same. Okay. Now, if we allow ourselves to have negatives, okay, or actually, I'm just going to type a negative in here just to make it work for us. So the first one I'm going to do here is the input. I'm going to give us a horizontal reflection. So what's going to happen is we're going to see this graph. It's it's going to get flipped. So this part here is going to come over here, and this part here is going to come over here. So it's going to flip it this way. In other words, taking this x-axis and it's flipping it over. So this -2 comes to this 2 and vice versa. So if I just hit it with a negative, we see we get that flip. Okay. Again, notice our y-intercepts stay the same, but we can see that we very clearly have this reflection, right? Now, if we think about what that negative did, it just made the input negative. And if we look at these points, right, these are two similar points. They have the same output because this is a horizontal transformation, but the input is now just the opposite sign. That's it. Okay, and now if I do a similar thing with A, it's going to flip our graph over. And again, we can see some of these values here. So same input at this point, but the outputs, because this is a vertical transformation, are opposite. Okay, so Desmos is really great. I really encourage you guys to take some time going in here and kind of working with this app, this kind of idea, this built-in transformations. Okay, as I said, inverse function is something we're going to deal with later on in the term, so you don't need to worry about that right now. Okay, so come in here, play around with this, mess around with this. If you need it to graph something later on in the term when we're working on like how to graph a function, absolutely feel free to jump in here and use this if you don't have a graphing calculator, or even if you do. All right, you guys, that's it for this video. We've got one more video coming out for transformations, so there's going to be 3 total. There's already the general notes posted. Here's the Desmos, and then next I'm going to post a example video where we're going to go through and actually look at transforming a function point by point and how that works.